give you, let's read it together. So it says in 1997, the average CO2 emissions of new cars in the UK was 190 grams per kilometer. In 2005, the average CO2 emissions of new cars in the UK had fallen to 169 grams per kilometer. Given that A grams per kilometer is the average CO2 emissions of new cars in the UK, N years after 1997. I'm going to highlight that because this is very, very important here. N years after 1997, right? And using a linear model, form an equation linking A with N. Yeah? So I'll give you guys a hint, right? We know that we're looking at a perspective of from 1997, yeah? Because it says that uh the new cars, the CO2 emission of new cars in the UK was N years after 1997, right? So in the first sentence, right, we've got a bit of information here. We've got information one, information two, yeah? Now, what does it tell us? It tells us that in 1997, right, the CO2 emission was 190, yeah? In 2005, the CO2 emission was 169, yeah? So can you see we've actually got two sets of information here, don't we? Right? And they also told us what these variables represent. Now, they told us that A is our CO2 emission, and that's in green, right? I'm going to color code this for you. And we know that N, right, is yellow. Yeah. So I need to highlight. Let me put this here. Put this in yellow here. This is N, isn't it? Yeah. We need to form an equation linking A with N. So this is N here, and this is A. Yeah. So we need to figure out our values for A and our values for N, right? Now, very quickly, guys, we agree that this represents N because this is our years, right? And this represents A. Yeah. Do we agree, guys? I want you guys to tell me yes or no. Because this is our CO2 emissions, do we agree that this is A, in this case, is 190? Do we agree with that, guys? Yes or no? I want you guys to tell me yes or no in the chat. Yeah? Good stuff. Now, this says in 1997, but it also says that N, right, is representing N years after 1997. So if we're in 1997, what do we think our value of N will be in the year of 1997? Because it's saying that N is representing years after 1997. What do we think our value of N would be in this case? Or if you think of it, let's see the chat. Good stuff. Exactly. Thank you very much, Fiona. It will be zero, isn't it? Because this is your start. Yeah. So what you could say is that, well, we've got N is equal to 0 and we've got A is 190. Yeah. That's for information number one. And then for information number two, right, we can see that A is 169 clearly. Can somebody tell me what our value for N would be in information number two? Exactly. Fantastic, Rihanna. Well done. It's going to be 8, isn't it? Because that's just 8 years after 1997. So N is equal to 8. Yeah. So you've got two pieces of information now. Now you can just do the exact same things we were doing. Remember, think about it as well, though. We've got N and we've got A. Remember, generally speaking, we've got Y is equal to MX plus C. Yeah. Remember, we have two types of variables. We have the independent variable and the dependent variable. Remember, in our case, right? X is the independent variable and Y is our dependent variable. The value of Y, right, depends on what X is. So in the case of our context, our question here, we've got CO2 emissions, right? And we've got the year. What do we think is independent here? Do we think the year or the CO2 emissions? What do we think is independent? The year or the CO2 emissions? Exactly. Thank you very much, Brianna. It's the year, isn't it? The year is independent of the CO2 emissions. The amount of CO2 emissions just depends on what year you're in, right? Because maybe in one year there was more CO2 emissions than another. So for sure, we can say that we're gonna have this here, right? We're gonna say that in our case, we're gonna say n is equal to x, and then that must mean that a is equal to y. So therefore, this just becomes a is equal to m and then n plus c. Yeah. So this here is our answer, and then now, how do we work this out then? Yeah, we need to form an equation linking n and c. So we a and n, sorry. So we need to figure out our gradient and our y-intercept, and we can do that because we've got 2 points, don't we? You can actually write these as coordinates, can't you? 0, 1, 90, and then 8, 1, 6, 9. Yeah. So it becomes y2 minus y1 over 8 minus 0. Sorry, that minus that. Sorry, other way around. 0 minus 8. 0 minus 8. Yeah. So therefore, let me just double check. Yeah, that minus that. Yeah, that's fine. This is just equal to 21, I believe. 17. Yeah, that's 21. And then over 8 over minus 8. Yeah, so this is our gradient. Is that correct? Yeah, that's 21. 190 minus 169 is 21. Yeah, yeah, that's fine. We all okay with this, guys? Yeah, good stuff. So this is our gradient now. So that means we can update this and say that our formula is A is equal to uh we can, that minus there, you can write on the outside, minus 21 over 8, and then n plus c. And then remember, we need to figure out what our y-intercept is here. That's fine. You just plug in one of the coordinates, don't you? So what I'm going to do is, oh, actually, to be fair, we can actually see from the question, right? We can actually see from the question that the y-intercept, right, is just clearly 190, isn't it? Because the x coordinate here is 0, right? So the y-intercept is 190, yeah? C equals 190 from here. So therefore, our complete model is A equals minus 21 over 8n plus 190. Anybody get this correct? I'll zoom out. And if you didn't get this correct, does this make sense now? Probably didn't give you guys enough time anyway. Just want to make sure this is all okay for you guys. Okay, good stuff, good stuff. Yeah, good stuff. And now let's just do part B, yeah, before we finish. It says, so this is our model, right? For the average CO2 emissions from the year 1997. It says in 2016, the average CO2 emissions of new cars in the UK was 120 grams per kilometer. Comment on the suitability of your model in light of this information. So we've got a factual statement here, right? We've got a factual statement here. This is a fact, yeah? And we have a model, right? Remember what we said at the beginning of the lesson. A linear model is just a model which constructs a real life situation. So what we attempted to do here was to create a model that determines the average CO2 emissions depending on the years after 1997. And they told us, well, in 2016, the average CO2 emissions was actually 120. And it says, comment on your suitability of your model in light of this information. Does anybody have any ideas as to what we should do? I'll give a couple of seconds. What do we think? Well, remember as well, in 2016, right? Remember, our model is modeling the years after 1997, right? So in our case, right, remember, our start was at 1997, yeah? And they're talking about 2016. What should our value for n be, do you think? Exactly. Thank you very much, Biana. It's 19, isn't it? Yeah? Does that make sense? I can see someone put 9, but I'm pretty sure you meant 19, isn't it? Yeah? N is equal to 19. Yeah? Good stuff. Yeah. And it says that it was 120. So do we agree, guys? If our model is suitable, right? When we plug in n equals 19, we should expect to get something of 120. Do we agree with that? Right? If we have a suitable model, because the model is meant to be correctly, accurately modeling the average CO2 emissions in any year. So when we plug in n equals 19, do we agree that we should be able to get 120 or thereabouts? Does that make sense? Is that reasonable to say? If anybody to say yes or no. Yeah? Okay. Cool. Good stuff. So let's plug that in then and see what that gives us. Yeah? So we're going to say minus 21 over 8, and then we're going to plug in 19, and then we're going to plus 190. This gives us 140.125. Yeah? So we could say that when n is equal to 19, a is equal to 100 and what was it? 140.125. Yeah? So what do you think of then? It says to make a comment on the suitability of your model in light of this information. So we know that the fact was that in 2016, A was 120. When we plugged it into our model, which was meant to be accurately representing the average CO2 emissions, we got 140.125. What do we think then about the suitability of our model? Is our model suitable, do you think, or not? Exactly. Thank you very much, Fiona. The model is not suitable. Yeah. So all you will need to do with a question is you'll say, since the average CO2 emissions is 140.125, which is considerably, can't spell today, off 120, the model is not suitable. And that's it. Does that make sense, guys? How do we find